Hey guys, happy virtual learning day. So this is the second out of 3 lectures for chapter 20. You should have, what am I doing? You should have, yes, done the table yesterday from page 547 with the different types of water pollutants. That is on your own, that's number 5. We're going to start with number 12. We'll do 11, 12. I don't know why, but 12 is first. So we talked about lakes. We talked about rivers. Now, if you remember the slowest flowing kind of water, that's going to be groundwater or aquifers. Okay, so the big problem is that this is where a lot of our drinking water comes from, right? And so what pollutes it? Fertilizers and pesticides that seep down, gas that seeps down. This would be like chemicals from factories. That's what that one would be. And then a big one is fracking, right? And we learned this last unit. So that one's kind of important. Oh, geez. Oh, geez. It always takes me a little bit to get used to it again. So you guys learned that. You've got the methane that is released into groundwater. You've got the fracking liquids that are released into groundwater. You can picture that lady setting her water on fire. So that's number 12. Okay, so what you end up getting is you get the location of the contamination, but then you get this spreading out. It's called a plume. Okay, it's called a plume. And think of it like ripples in a pond. Maybe the contamination's right here, but then underground, maybe this is underground, the contamination's right there, but then it all stretches and it's affecting this house over here, even though even though the source is right there. So you have this aquifer, this underground river, right? And you've got these sand, gravel, bedrock layers, and the water saturates it, and then it just spreads. So think about that. That is one of the reasons that groundwater is so very tricky. And so number 11, why can't it cleanse itself very well? This is pretty important. I would put a star by number 11. Number 1 is the slow flow. That's probably the most important thing. The time it takes for groundwater to recharge itself is incredibly slow. Because it's underground and it's not exposed to air, we have less dissolved oxygen, which means we have less organisms available to decompose. Okay, which is the next one. It's cold. Enzymes don't work so well in the cold. Usually as you heat things up, particles collide more and more chemical reactions happen. And then finally, we can't get to it. Like, it's underground. So if you look at the picture, you see the factory has this underground tank that's leaking, and then you see this big plume of contamination. You see a house with a well, and eventually you have this river that's like way down here that also gets contaminated. So when you're looking at types of groundwater pollution, like number 13, okay, here are 3. One is nitrates. So this is what the FDA reports toxins that are found in aquifers. So like think about fracking. So nitrates can turn into nitrites, which can cause stomach, colon, and bladder cancer. This is why a lot of people buy nitrite-free hot dogs. It's also in cured meat. It can also cause blue baby syndrome, where the blood cells lack the ability to carry enough oxygen. So the ions can block the red blood cells from the hemoglobin from attaching to the oxygen. Number 2, we talked about DDT yesterday. DDT persists in the atmosphere and in water. Okay, so it degrades really slowly. It's not water soluble. We talked about it with like the Milwaukee River as well. And then things that don't break down at all, metals, remains in the water permanently, like lead, like arsenic, which are both neurotoxins. Okay, so those are some types of groundwater pollution. And so like yesterday when we talked, we said, excuse me, prevention is way easier than cleanup, right? And so like, what do? So here's one of these T-chart tables, and it says for number 14, list 2 ways to prevent and 2 ways to clean up. Here are the ones that kind of stick out to me. One of them is find substitutes. Where's that one? Right away, right here. Find substitutes. Use something else. Instead of using cleaning products with phosphates, use like vinegar and water to clean. And then the other one that I wrote down is this top one, ban toxic chemicals out of the environment. You could require underground tanks to have leak detectors. We'll talk about hazardous waste next week, and then also the liquids. Once it happens, now what do? So one thing we do is we bring it all to the surface, then we clean it, and then we put it back in the aquifer, which seems ridiculous. Like, it's super expensive, and it's really not that, I don't know, efficient. Another one is to inject bacteria in there. So if it's biodegradable waste, we can inject microorganisms. Now, again, that's going to drop the oxygen levels, which is that's an issue in and of itself. So I would say both of these issues. How do I change my color? Here we go. Both of them are gray. No, thank you. What the heck? I don't know why that's not working. Okay, both of them are expensive, and both of them are relatively ineffective. So keep that in mind too. Prevention is the way to go. So when we're looking at purifying drinking water, because now we're talking about effect on humans, there's lots of ways to do it. So think about developed countries like us. What happens with our drinking water? So we have these reservoirs where you store the water for a long time. It improves the clarity, it improves the taste because we raise the oxygen levels and we allow anything that's kind of like floating in it to settle. So this is number 15. Okay, and then we also take, well, you could take sewer water. Like yesterday we talked about the Fox River and how the water is treated and then put into the Fox from the sewer treatment plant. You could actually send that water back to Brookfield to drink. Now think about your parents finding out that their toilet water gets cleaned and pumped right back to us to drink. There tends to be a lot of opposition from cities. The technology is there, but just the idea of it doesn't rub people the right way. In underdeveloped countries, you've got kind of three options here. So this is the other part of number 15. You can put it in, UV sunlight kills microbes, like it causes cancer in us, and it kills really little things. So you can put the water in clear plastic containers, inexpensive, portable containers that sunlight hits and kills the microbes. There is something called a life straw, which is in this picture, I believe. You've got this portable water filter that's pretty cheap, and it eliminates a lot of the viruses and the parasites. And so I don't know if this picture is from Africa. It doesn't really look like it, but that's where I've heard of it being implemented a lot. And then you've got the pure powder released from the pure water filter people, and that's what this lady is showing. So you got this water, that brownish water is what she removed from her water source. You add this chlorine, that's a disinfectant, and then iron sulfate. You let it sit for like 20 minutes, and then you pour it through a cloth and everything sticks, and what you get is the water that's on the left. Okay, so those are ways in developing countries to protect your water. So now we come to one of the laws. You guys know that I hate laws and I hate acts, and I think they're silly to memorize. However, we've got some pretty important ones that I'm not going to skip over. So number 16 asks about U.S. laws for protecting drinking water. It's not just water in general, it's very specifically drinking water. And in 1974, the Safe Drinking Water Act was enacted, and it sets maximum contaminant levels for 91 different pollutants, including lead, including arsenic, including DDT, and a lot of other things. It's in blue because all of the acts and laws are going to be in blue. Okay, so the question asks, it just says to summarize it. A lot of people want to make it stronger. A lot of people say that it's too much. Okay, so health scientists say not enough. A lot of times these small cities have issues passing like the standards, and so they want to combine it with larger systems. This is one of the Flint, Michigan issues, is they were going to be on Detroit water, so making it easy for the small ones to meet standards, to strengthen and reinforce public notification. So like you get a water report in the mail every year, your parents get a water report. I don't know that everybody always looks at it. And I think that people assume that if they get a piece of paper, everything's good to go. But there are times that our water report is talking about exceeding like radium levels in water around here. So like we do get a report, it's just not publicized. And then lead pipes are a big issue. And this is what happened in Flint, Michigan. So if you've heard of Flint and the water crisis, there's a video, but since it's a virtual lecture, we're not going to watch it. In 2014 is when the problems started. People started noticing like discolored water. Kids were getting sick, and it was getting worse and worse and worse. They brought it to the government's attention. They said no, like they had switched from Detroit water to their own water. It was largely ignored by the governor at that point. Fast forward to 2017, for a long time they were providing bottled water. The federal government was providing bottled water. In January 2017, the EPA, Environmental Protection Agency, said that lead limits were below the federal limit, which is 12 parts per billion. Now remember, lead, we haven't learned it yet, we'll learn it next week, but it affects your kidneys, your heart. It's a neurotoxin in kids, cognitive delays, behavioral issues, hearing problems. And as almost exactly 1 year ago, the government ended the free bottled water for Flint. The government said that it was safe. Now, if you lived in Flint, would you trust your faucet water? I don't know. So in the meantime, Will Smith's son said that he'd provide a bunch of bottled water to Flint. I don't know whatever happened with that. I was trying to look for that in the news. And then as of this fall, a new governor was elected in Michigan, and her priority was to make bottled water available to residents if they still needed it. And as of last month, like February, well, 2 months ago, I guess, 90% of homes were way under federal lead levels. So we're making progress, but like, why is it taking 5 years? So that's Flint. All right, where are we? 17. Coastal waters. So in less developed countries, oftentimes like toilet water, shower water, and whatnot are just dumped into oceans without treatment. Remember that when we talked about water, that the ocean is viewed as this inexhaustible resource. We talked about the tragedy of the commons, and hey, like me dumping my, I don't know, bedpan full of pee isn't going to matter because the ocean's so big. So that's kind of the attitude of some people in less developed countries. They don't really have an option. 80 to 90% of municipal sewage is dumped without treatment. Okay, so the 17 talks about that. You should talk about raw sewage. A lot of times raw sewage will have viruses in them because the wastewater treatment plants don't remove viruses, even in the US. You got these nitrates and phosphates that we talked about, which causes eutrophication, which causes harmful algal blooms. And then when they die, you have this depletion of oxygen, right? So 1/4 to 1/3 of people using beaches on the coast in the U.S. develop ear infections, sore throats, eye infections, respiratory issues, or stomach issues from swimming in that contaminated water. So think about Bradford Beach. Think about those signs that you see. Okay, so then 18 asks about algal blooms. The key here is this oxygen-depleted zone, that when the algae die and get decomposed, the aerobic bacteria that are decomposing use the oxygen and deplete it. So same thing as culture eutrophication. Ooh, we might make it under 15. So this kind of details some of the things we talked about. Dumping, oxygen depleted zone. Red tides are similar to culture eutrophication, but a very specific type of algae. This goes back to like HIPCO with the ocean as well. You see the fishing issues right here as well. And then the last thing before oil spills, which I'm going to save, is garbage patches. So believe it or not, there are two. This is discovered the year I graduated from high school. Like it's relatively recently. I'm kind of old, 1997. But you have these two big rotating circles of plastic that are just beneath the surface of the ocean. Both of them are the size of Texas, which is nuts. You have these tiny plastic pieces, so like the size of like rice grains to the size of like pencils, that are just below the surface. You can't really see them from the top. It's difficult to measure, and it's really, really hard to clean up. And so we kind of got to focus on prevention here. Okay, so this should have taken you through slide 19. I'm sorry. Well, no, it is slide 19. It's also question 19. The second part of the lecture, we're going to skip oil stuff, and I'm going to start later on. So take a break, get a drink of water, watch the video if you want, and I'll see you soon.